everyone. Happy to see you all. So, here in the session, we are going to discuss the AIET 5 JEE solutions for class 11. Okay. So, I have brought some important questions and the questions which you feel very difficult to solve. Okay. So, let's start from the first. The first question from the paper is question number 26. So the question says that consider the reaction 2A plus 3B giving C. Initially, there were 2 moles of reactant A and 3 moles of reactant B. Then which of the following statements is true? So the given reaction is 2A plus 3B giving C, right? And initially we have 2 moles of reactant A and 3 moles of reactant B, and we have to find out the correct option, right? So in the reaction also we have 2 moles of A and 3 moles of B. Okay. And the given amount is also same. So A and B react in the ratio 2:3, right? A and B react in the ratio 2:3 according to the given equation. So since we have the reactants in the exact same ratio, both will get consumed at the same time. Both A and B will get consumed at the same time. Okay. So option B is the correct answer for this question. Okay. So both of them are in the same ratio. The amount given is also same. So both of them will get consumed at the same time. Okay. So option B is coming out to be the correct answer. Then moving on to question number 27. So the question says, consider a mixture of hydrogen and oxygen where the mole fraction of hydrogen is 0.5. In this mixture, what is the ratio of masses of hydrogen and oxygen? Okay, the atomic mass of hydrogen and oxygen is given as 1 and 16. So we are asked to find out the ratio of the masses of both the elements. Okay. And the given value is the mole fraction. The mole fraction of hydrogen is given. So mole fraction is denoted by the letter X. So if I keep hydrogen as component 1 and hydrogen as component 1 and oxygen as component 2, then the mole fraction of hydrogen, which is component 1, it is equal to 0.5. Okay. And we all know that sum of the mole fraction will be equal to 1, right? So x1 and x2 should be equal to 1. So here x1 is 0.5, then x2 is obviously 0.5 again. So x2 is also 0.5. Okay. So then only if we sum up these two values, we will get 1. All right. So since the mole fractions are same for both the component, okay, for hydrogen and oxygen, the mole fraction is coming out to be same. So therefore, from this, we are concluding that number of moles of hydrogen and oxygen will also be same. Okay. Since the mole fraction is same, the number of moles will also be same. So the number of moles of hydrogen and the number of moles of oxygen will be same. So let me keep it as 1 and 1. Okay. Now we can substitute. So we know that number of moles is equal to the given mass divided by molar mass. Right? Number of moles is equal to given mass divided by molar mass. So what is the number of moles of hydrogen? It is the given mass of hydrogen divided by the molar mass of hydrogen. Coming out to oxygen, it is given mass of oxygen divided by molar mass of oxygen, which is equal to 1 by 1. Okay, now if we substitute the values, The given mass of hydrogen, no, the mass of hydrogen is not given. So we have to find out the ratio of those two. So let me write as it is. Molar mass of hydrogen is 2. Why? For one hydrogen, for atomic hydrogen, it is 1. And we have 2 hydrogen in the molecule, right? So it should be 2. So molar mass of hydrogen is 2 divided by the mass of oxygen. Mass of oxygen is also not given, divided by molar mass of oxygen. So for atomic mass, it is 16 and the mass will be 32. We have 2 oxygen, right? So it will be 32, which is equal to 1 by 1. Okay. So now if we cancel this, we will get 16. So the ratio of hydrogen, ratio of masses of hydrogen and oxygen is equal to 1 by 16. Okay. So the ratio is coming out to be 1 by 16. So option C is the correct answer for this question. Option C is the correct answer for this question. So very easy. If the mole fractions are equal, the number of moles will also be equal. Okay. And from the number of moles formula, we have the ratio of their masses. So let's go for the next. This next question is question number 30. The correct order of the radii of the isoelectronic species is potassium, Cl minus, and calcium. So we have 4 different orders. We have to find out the correct order. Okay. So we all know that for isoelectronic species, for isoelectronic species, the ionic size is inversely proportional to their atomic number. Ionic size is inversely proportional to the atomic number, right? So since all the 3 ions have same number of electrons, we have to go with the atomic number. Okay. So the atomic number for calcium is 20 and for potassium it is 19 and for chlorine it is 17. Okay. So the one which is having the least atomic number value, the largest size. Okay, as you can see here, chlorine is having the least atomic number value. Atomic number is denoted by the letter Z. Okay, so chlorine will be Cl minus will be greater in size. Then comes potassium K plus and calcium 2 plus. Okay, so for isoelectronic species, the ionic size is inversely proportional to atomic number. Okay, so all of them have same number of electrons. Calcium is having 20 electrons and if it loses 2 electrons, it will have only 18. Potassium has 19 electrons. If it loses 1, it becomes 18. Chlorine has 17 electrons and if it gains 1 electron, it will become 18. So all of them are having 18 electrons. Okay, so in that case, you have to go for this particular relation. All right. So just by applying this relation, we can get the correct answer. And the correct option is option D. The correct option is option D. Okay. So let's go for question number 33. In the following set of questions, a statement 1 is given and a corresponding statement 2 is given below it. Mark the correct answer as if both statement 1 and 2 are true and statement 2 is the correct explanation of statement 1. If both statement 1 and 2 are true, but statement 2 is not the correct explanation of 1, statement 1 is true, statement 2 is false. Both 1 and 2 are false. So these are the options. The statements are given at the bottom. Statement 1 says, the removal of an electron takes place from pi bonding orbital when nitrogen converts to nitrogen plus. So before going into the answer to check whether it is true or not, let me give you the molecular orbital energy level diagram for this nitrogen. Okay, so let me draw the p orbital alone, p molecular orbital alone. So we know that nitrogen has the atomic number of 7 and the electronic configuration is 1s2, 2s2 and 2p3, right? So let me draw the 2p orbitals. So the 2p orbital of the first nitrogen is here and it has 3 electrons in it, and the 2p orbital of second nitrogen is here and the 3 electrons are located like this. Okay, and if these 6 atomic orbitals combines, so these are the atomic orbitals. Okay, so if these 6 atomic orbitals combines, they form 6 molecular orbital, right? So the number of atomic orbitals combining is equal to the number of molecular orbitals formed. So 6 orbitals combine to form the 6 molecular orbital. So here is 2, 1. And above we'll have 2. And above that we will have 1. Okay. So the names of these molecular orbitals are, here we have pi 2px, pi 2py. This is called as sigma 2pz. So these 3 orbitals which are lying lower in energy. So if energy is increasing like this, so these 3 orbitals are lower in energy compared to the atomic orbital. So these are the molecular orbitals, okay? N2 molecular orbital. So those 3 orbitals are called as, these 3 orbitals are called as bonding molecular orbital. Okay? And the above 3, which is called as pi star 2px, this is pi star 2py, and this is sigma star 2pz. So these 3 orbitals are called as anti-bonding molecular orbitals. All right. So we have 6 electrons now and we have to fill all the 6 electrons according to Aufbau's principle, Pauli's exclusion principle and Hund's rule. Okay. So according to those rules, let me fill the 6 electrons. 1, 2, 3, 4, 5 and 6. All right. So this is the MO diagram for N2. This is the MO diagram for N2. Got it? Now, when nitrogen gets converted to N2 plus, when nitrogen gets converted to N2 plus, the removal of electron is from sigma 2pz, right? Because that is the highest occupied orbital. And N2 to N2 plus means we are removing one electron from N2. So the removal of electron will be the last electron. Only the last electron will be removed. So the last electron is present in sigma 2pz and that electron will get removed. Last electron which is present in sigma 2pz will be removed. But in the statement it says that the removal of electron takes place from pi bonding orbital. Pi bonding. It is bonding. The removal of electron takes place from bonding molecular orbital only. But it is not pi bonding. It is sigma bonding orbital. It is sigma bonding orbital. So, statement 1 is wrong. Okay, it is false. Then if I go for statement 2, bond order increases by 0.5 when N2 converts to N2 plus. So there is one trick to find out the bond order, right? From the number of electrons. So if the number of electrons is equal to 14, then the bond order is equal to 3. Okay. So if it goes to 13, then it will be 2.5. If it is 12, then it is 2. If it is 11, 1.5. The number of electron is equal to 10, then the bond order is 1. And in the same way, if you go below, if we have 15 electrons, the bond order is 2.5. If we have 16 electron, it is 2. If we have 17 electron, it is 1.5. And if it is 18 electron, it is 1. Okay. So now let us calculate the total number of electrons in N2 and N2 plus. So for N2, so nitrogen has the atomic number of 7. So there are 2 nitrogens. So 7 plus 7 is 14. And when you go for N2 plus, so N2 has 14 electron, but it is losing 1. So that's why it is gaining N2 plus charge. So 14 minus 1 is equal to 13. So for 14, bond order is 3. For 14, bond order is 3. And for 13, the bond order is 2.5. So what is happening? When nitrogen is getting converted to N2 plus, the bond order decreases by 0.5. The bond order decreases by 0.5. It is not getting increased by 0.5. Okay, so statement 2 is also false. So both the statement 1 and 2 are false is the correct answer. So option D is coming out to be the correct option for this question. Okay, option D is the correct answer for this question. Clear? So now let's go for question number 34. Calculate the standard free energy change. Standard free energy change. It means standard Gibbs free energy change, okay, which is called as delta G naught. So we have to calculate this. For the formation of methane at 298 Kelvin, the value of delta H of formation for methane is given, and the entropy is also given for carbon in graphite form and for hydrogen gas and for methane gas. We have to find out the delta G naught from these given information. So how to find out? What is the formula to find out? Delta G naught is equal to delta H naught minus T delta S naught, right? Delta G is equal to delta H minus T delta S is the formula. All right. So we have the delta H value in the question. And also we have temperature in the question. We have temperature. We have delta H value here for methane. But we don't have delta S value. Instead of delta S, we have the entropy values for each and every molecule. Okay. So initially what we have to do, we have to find out delta S and then we have to substitute the values here in this formula. Got it? So let me write the equation first. So we have to write the equation, then only we can know which is the reactant, which one is the product. Okay. So it is for the formation of methane. It is for the formation. So carbon in graphite form will react with hydrogen to give methane, CH4. Okay. So we have to balance this equation. So let me put 2 here. So this is the required equation and the delta H value is given. So let us find out the delta S value. Delta S naught is equal to summation of delta S of product minus summation of S naught of reactant. S naught of reactant. Okay. So who is the product here? Methane is the product. And the methane entropy value is given. It is 186.3. 186.3 minus. Now let's come to the reactant. We have 2 reactants. One is graphite and the S naught of graphite is 5.70. And we have 2 moles of hydrogen, right? So plus 2 into hydrogen entropy value is 130.7. Okay. So this is in terms of joule per Kelvin per mole. Okay. Clear? So now if we multiply and if we add and subtract, we will get the answer as minus 80.8 joule per Kelvin per mole. So if we want to convert this into kilojoule, we have to multiply by the number 10 power minus. Okay, so it will be 80.8 into 10 to the power minus 3 kilojoule per Kelvin per mole. So why I have converted this to kilojoule from joule? It is because all the options are given in terms of kilojoule. Okay, so that's why I am converting the joule to kilojoule here. Okay, so now this is the value of delta S. So now what we can do, we can substitute this in the required equation. So delta G is equal to delta H. Delta H is minus 74.81 minus temperature. Temperature is 298 Kelvin into delta S is minus 80.8 into 10 to the power minus 3 kilojoule per Kelvin per mole. Okay. So now if we solve this, it will be minus 74.81. So if we multiply this, we will get 24.07 kilojoule per mole. Okay. So delta G naught is coming out to be minus 50.74 kilojoule is 7. Okay. 74 kilojoule per mole. Okay. So correct answer is option C. Correct answer is option C. So what we are doing here, we are taking the required equation and we need one term to solve in that equation to get substituted. So that term is delta S and delta S is getting calculated from the other formula, from the given information. So we are substituting the given values and finding out the value of delta G naught, which is standard Gibbs free energy change for the formation of methane. Okay, so just remember the steps that has to be followed. So there are only two things you have to keep in mind. One is delta S formula, the other one is delta G formula. That's all. Okay. So now let's go for question number 36. Assuming that the degree of hydrolysis is small, the pH of 0.1 molar solution of sodium acetate will be. So we have to find out the pH, right? We have to find out the pH and the concentration is given 0.1 molar solution. The compound is sodium acetate. Sodium acetate. It means CH3COONA. So sodium acetate is a salt of, it is a salt of strong base and weak acid, right? It is a salt of strong base and weak acid because CH3COOH, this is a weak acid, okay, and NaOH, it is a strong base. So if we mix these together, we will get CH3COONA plus H2. So this is a salt of strong as weak acid and strong base. Okay. So for the salt of strong base and weak acid, the formula to find out the pH will be equal to 7 plus 1 by 2 pKa plus log C. This is the formula. All right. So now we need to check the required terms. So in the formula, we have pKa and log C. So C is called as concentration and that is given in the question, but pKa is not given. Instead of that, Ka value is given. So first we have to find out pKa from the Ka value. So we know that pKa is equal to minus log of Ka, right? So which is equal to minus log of 1 into 10 to the power minus 5. So if you bring log to both, so apply log to both, so it will be minus log 1 plus log 10 to the power minus 5. Okay. So we all know that log 1 is 0 and log 10 to the power minus 5 is minus 5. Okay, so pKa is equal to plus 5. pKa is equal to plus 5. And also we have the C value. C is concentration. So what it is? Log C is equal to log of 0.1. So log of 0.1 can be written as log of 10 to the power minus 1. So log of 10 to the power minus 1 is minus 1. So log C is equal to 10 to the power, log C is equal to minus 1. So we can substitute the values of pKa and log C in the required equation. Okay. So therefore, pH is equal to 7 plus 1 by 2 of 5 minus 1. So 5 minus 1 is 4 and 4 by 2 is 2. So 7 plus 2 is equal to 9. So therefore, the pH value is equal to 9 for this sodium acetate solution. Okay. Option D is the correct answer. Option D is the correct answer for this question. Okay. So now let's go for question number 39. To an equilibrium mixture, 2SO2 plus O2, which is in equilibrium with 2SO3, some helium, which is an inert gas, is added at constant volume. The addition of helium causes the total pressure to double. Addition of helium causes the total pressure to double. Which of the following is true? So we have three gases, right? So which one is true? So we know that helium is an inert gas and it is also given in the question. Okay. So at constant volume, the addition of an inert gas, the addition of helium, which is an inert gas, has no effect. Okay. Addition of helium has no effect. So this is the conclusion. So the concentration of the three gases is unchanged. Concentration of the three gases is unchanged. Option A is the correct answer for this question. Okay. So for constant volume, there is no effect of addition of an inert gas. All right. Now let's go for question number 40. Given below are two reversible reactions whose equilibrium constants are given. A plus B is in equilibrium with Z, and equilibrium constant is given as 24, and for 2B plus C giving 2Y, it is equal to 60. So the required equation, compute the equilibrium constant for the required equation, which is A plus Z is equal to A plus Y is in equilibrium with Z plus half of C. So we have to take this equation from the given equation. So we have A in the reactant side and Z in the product side in equation 1. So let it be as it is. Okay, this is K1. And in the second equation, if you see, we have a 2B plus C, which is in equilibrium with 2Y. So Y is in the product side and here Y is in the reactant side. So what we have to do, we have to reverse equation number 2. So if we reverse equation 2, we will get 2Y, which is in equilibrium with 2B plus C. Okay. So the equilibrium constant will be, since I have reversed the equation, I have to take the reciprocal, right? So it is 1 by 16. It is 1 by 16. Okay, K2 dash is equal to, this is K2, 16 is K2, K1 is 24 and K2 is 16. And if I reversing the equation, I have to take the reciprocal. So it is 1 by 16. Now, what we have to do? We are having half mole of C in the product side in the desired equation, but we have C in the reactant side here. So I have to multiply this equation, multiply this second equation by 1 by 2. So if I multiply this equation by 1 by 2, I will get y, which is in equilibrium with b, plus 1 by 2 of c. So since I have multiplied this, so that multiplied number has to go to the power, right? So K2 double dash is equal to 1 by 16 power 1 by 2. Okay, it is power 1 by 2. So now this is the equation. This is the required equation. This is the required equation. And we have to add K1 and K2. Next, what we have to do? Add K1 and K2. So K dash is equal to, if I am adding two equations. So let me add first. Let me add first. So let me add first. So K1 is equal to add equation. This is equation 1 and this is equation 2. Add equation 1 and 2. Okay. So which is A plus B in equilibrium with Z and Y which is in equilibrium with B plus half of C. So here what happens? B will get cancelled with each other. So A plus Y is in equilibrium with Z plus half C. So this is the required equation and we are getting this equation by adding the two. So what we have to do? The new equilibrium constant will be equal to the multiplication of these two. So it is K dash which is equal to K1 into K2 dash, double dash. Okay. So K1 and K2 double dash. So if I'm adding two equation, I have to multiply the equilibrium constant. If I am multiplying by some number, that has to go to the power. If I am reversing the equation, then I have to take the reciprocal. Okay. So these are the properties which we have learned. Okay. These are the properties of equilibrium constant. So we have to go accordingly. So now multiply the equilibrium constant. K1 is 24. K2 dash is 1 by 16. Power 1 by 2. So 1 by 16 is nothing but 1 by 4, right? 1 by 4. If we take the root of 16, we will get 4. So let me substitute 1 by 4. So 4 and here by solving, we will get 6. So K dash is equal to 6. K dash is equal to 6. So option B is the correct answer for this question. Okay. K dash is equal to 6 is the correct answer for this question. All right. So let's go for question number 42. In the following reaction, 4P plus 3 KOH plus 3 H2O giving 3 KH2PO2 plus PH3. Phosphorus is only oxidized. Option B, phosphorus is only reduced. Option C, phosphorus is both oxidized as well as reduced. And option D, none of the above. So we have the equation and we have to check for the oxidation number of phosphorus. Okay. So for that, what we need to do, we have to find out the oxidation number. So let me write the equation first. 4P plus 3 KOH plus 3 H2O giving 3 KH2PO2 plus PH3. Okay. So the elemental phosphorus will have zero oxidation state. Okay. And here in the product side, if I check for the oxidation number of this phosphorus, let me take it as X. And for potassium, it is +1. And for hydrogen also, it is +1. So we have 2 hydrogen +2 plus X. Now for each oxygen, it is -2. I have 2 oxygen. So 2 into -2 is -4, which is equal to 0. So X is equal to 4 minus 3, which is equal to +1. So the oxidation state of phosphorus here in this compound is +1. And for phosphine, let me take this as X, and for each hydrogen it is +1. So +3 is equal to 0 and X is equal to -3. X is equal to minus 3. The oxidation state of phosphorus in the product side is minus 3. So now, in one compound, phosphorus is moving from 0 to plus 1. 0 to plus 1 means it is moving towards the positive side. Okay. So there is increase in the positive charge. So this is oxidation. Okay. So and in the other case, phosphorus is moving from 0 to minus 3. Minus 3 means there is decrease in the oxidation number. So it is reduction. It is reduction. So phosphorus is both oxidized as well as reduced. Okay. So option C is the correct answer for this question. All right. So let's go for the last question of this session. The question says, how many of the compounds given below isostructural with carbon dioxide? So what is meant by isostructural? Iso means same. Structural means structure. So we have to find which among the following structures are similar with CO2 structure. So the structure of carbon dioxide is linear. C double bond O, C double bond O. It is linear. Okay. So now let's check one by one. Let me start with sulfur dioxide. Sulfur dioxide is S double bond O with one lone pair, because sulfur has 6 valence electrons, right? So the shape is bent. The structure of SO2 is bent. And when you go for C2H2, C triple bond C, H and H. C2H2. It is linear. C2H2 is linear. Then when you check for SnCl2, tin belongs to carbon group which has 4 valence electron. Out of 4, 2 has been used for bonding and the remaining 2 is present as lone pair. So again we are getting a bent structure here. And for NCO minus, it is N triple bond C, O minus. So we are having linear structure for this molecule. Then for carbon disulfide, carbon has 4 valence electron and it is getting shared with sulfur like this in a linear fashion. So out of these 5 compounds, 1, 2 and 3 compounds are isostructural with carbon dioxide molecule which are linear. Okay. So the correct answer is 3 for this question. Okay. So 3 compounds are isostructural with CO2. Okay. So I hope the session is very useful. Okay. For all of you who are watching the session here. So thank you so much. So I will meet you with the next set of questions from the AIET next time. Okay. Thank you so much. Take care. Bye-bye.